Section 9.1, we're going to look at the basics of significance tests. Just a reminder that this is a review of the activity that we did with Coach Rivers free throws in class. So if you were absent or if you just need to review some of the information, this video is for you. Otherwise, it is not required. Okay, so Coach Rivers says that he is an 80% free throw shooter. If you don't know much about basketball, that means he's saying that he makes 80% of every free throw that he takes. To prove his skills, we head down to the gym. He takes 50 shots and he makes 32 of them. 32 out of 50 is, of course, 64%. So is Coach Rivers exaggerating about his free throw skills? All right, first thing we got to do, we got to identify some information here. So our population is every free throw ever taken by Coach Rivers. Our sample is the 50 shots that he just took. Parameter is going to be P, the proportion of all free throws that he makes. And then our statistic is going to be P hat, which is the sample proportion, 32 out of 50, or 0.64. Okay, so 64% is not the same as 80%. What's going on here? We got two possible explanations for why Coach Rivers only made 32 out of 50 shots. So our possibilities is Coach Rivers telling the truth. He really is an 80% free throw shooter, but he was just off that day. It just happened to be a bad day for him. This is also known as sampling variability, right? Every sample of 50 shots is not going to be exactly 80%. The other option is he's exaggerating. He doesn't really make 80%, and that 64% is more in line with his true shooting ability. How do we know which one is the right explanation? Okay, we're going to do something called a significance test. You may also hear it called a hypothesis test. Okay, and this is like the big meat of statistics is these tests where we test two competing claims. Those are those explanations that we just talked about. Either he does make 80% of his free throws or he makes less than 80% of his free throws. All right. The claim that we kind of assume is true or that we're weighing evidence against is called the null hypothesis. You might also hear the term like the hypothesis of no difference. Okay, that's the one that we're just assuming the status quo is true. And then we are testing our alternative hypothesis. Okay, and so we like to think about it the way that the criminal justice system works in the US is all criminal or all accused people are assumed innocent, and we have to provide convincing evidence to prove that they are guilty. Okay, so the null hypothesis is innocent. And then if you want to, put somebody in jail or have them fined for committing a crime, we have to provide convincing evidence that that null hypothesis is not true. We have two different kinds of hypothesis or tests that we can run. One is called a one-sided test. And so that's when we're using the words greater than or less than or any synonyms of those words. Okay. Then we can also do what's called a two-sided test, which just means if it's different at all. We're not saying less than or greater than, we're saying either one. Either one is fine if it is far enough different from our null hypothesis. Important thing that we want to note is we are always going to make hypotheses about population parameters. So we're never going to talk about things from a sample. So when we write our hypotheses, we're always going to write them about population, all right, proportion or population mean. We are not going to use p hat. We are not going to use x bar. We write hypotheses about the population, not the sample. All right, so we have Coach Rivers. He claims he makes 80%. He did a random sample of 50 free throws and made 64%. So I have some evidence that P equals 0.80 is not true. I have some evidence that he makes less than 80% of his free throws. But is this evidence convincing? And to answer that question, we have to know how likely is it, or what's the probability that an 80% shooter would make 64% or less? Okay, because every 50 free throws that an 80% shooter takes, they're not going to make exactly 80%. Sometimes they're going to make a little more, sometimes they're going to make a little less. 80% is like that average value. All right, but how likely is it that they only make 64%? And the probability of that happening is called the p-value. All right, it's the probability of getting a result that is as extreme or more. So what's in context of our Coach Rivers example, what's the probability of getting 64% or lower if he really is an 80% free throw shooter? And there's a couple different ways we can figure out this probability. We'll learn the mathy ones later in the unit, but what we're going to do is use simulation to estimate a p-value. So in class, we went through the whole activity, but basically here are the results at the end. An 80% free throw shooter, and we did samples of 50 shots. So there are, I believe, about 2,000 different samples of 50 shots. And you can see like most of them are around 80%, which would make sense if you're an 80% free throw shooter. Okay. And we want to know the probability of getting less than 64%. Okay. And that ended up being 6 times out of our 2,000 results. So 0.6% of the time, right? 0.6% of the time, an 80% free throw shooter will make 64% or less. Okay, so here is how we interpret p-values. There's a sentence template there for you. So assuming that Coach Rivers is an 80% free throw shooter, right? Because we always assume that the null hypothesis is true. There is a 0.006 probability of getting a sample proportion of 0.64 or less purely by chance. So now we have to make our conclusion, okay? We have this p-value. We know what the probability of this happening is. What does that mean, okay? And so if the p-value is small, we reject the null hypothesis. That's the terminology that you're going to use. Reject the null hypothesis. And we can say that there is convincing evidence for the alternative hypothesis, okay? If the p-value is not small, we would say that we fail to reject the null hypothesis and there is not convincing evidence for the alternative hypothesis. Now, very important, we use this term, fail to reject. You cannot say accept, okay? We cannot accept the null hypothesis. We cannot say that we are proving the null hypothesis is true. We can only talk about whether or not we have convincing evidence for the alternative hypothesis. Again, think back to our criminal trial analogy. When they come back with a verdict, they either say guilty or not guilty. They don't say innocent, all right? Because we presume that they are innocent, and it's either we have evidence they're guilty or we don't. Okay, so we fail to reject, we never accept the null hypothesis. Okay, but we have to say, what do we mean by small? Okay, when we did problems previously where we were looking at simulations, we kind of used 5% as a guideline. That would be saying like any p-value that is less than 0.05 is small. Okay, sometimes they use different numbers. They use 0.01, 0.10 in significance tests. Okay, so let's talk about kind of what that means. We have a number. It's called the significance level, and its notation is the Greek symbol alpha. Okay, and that's the value that we're going to use as a boundary. Okay, a lot of times it's 0.05. It could also be 0.01 or 0.10. Those are the most common used ones. It can really be anything, but 0.01, 0.05, and 0.10, those are the most common significance levels that you would see. Okay, and this always needs to be set before you do the test. All right, so we use this significance level when we are writing our conclusions. Okay, so here's our template. Because the p-value is either less than or greater than alpha, our significance level, we reject if it's less than, we fail to reject if it's greater than. Okay, and then we do have evidence if we are rejecting the null, we do have evidence for the alternative. If we fail to reject, then we do not have evidence for the alternative. Okay, So that's the colors match up. If you're saying less than, then you should say reject and do have evidence. If you're saying greater than, you should say fail to reject and do not have evidence. If your p-value ends up being exactly equal, it rarely happens because we take those things out to like 4 decimal places, but if your p-value happens to be exactly equal to your alpha, we're going to use greater than or equal to. Okay, so if it's equal to alpha, we're also going to fail to reject there. Then last thing we got to talk about is what happens when we mess up. Okay, we hope that our significance testing procedure goes well and everything is in line, but we're dealing with sampling variability and other things. Sometimes stuff goes wrong. Okay, so we can classify our mistakes as one of 2 types of errors. So if we have a type 1 error, we would reject the null when we really shouldn't. Okay, if we have a type 2 error, we fail to reject when we should be rejecting. Okay, so type 1 error, I reject the null when I should fail to reject. Type 2, I fail to reject when I should reject. Okay, and the biggest thing is to be able to identify these things in context of the problem that we're talking about. All right, so type 1 error in the context of Coach Rivers' free throws. If I reject the null hypothesis and I say he makes less than 80% of his free throws, when in reality, he does really make at least 80%. Okay, a type 2 error in context would be if I fail to reject. So I say Coach Rivers does make 80% of his free throws, but in reality, he actually makes less. All right, and then a question that you will see a lot of times about these type 1 and type 2 errors is, which error is more serious? Now, in the grand scheme of things, whether or not Coach Rivers is an 80% free throw shooter is not like a life and death situation, all right? But this is what they will ask a lot of times is which error is more serious. So let's say that we have at the end of the game, we have the other team gets a technical, right? And so we need to pick somebody on our team to make 2 free throws, all right? If I'm deciding whether or not I want Coach Rivers to take those technical shots, okay? If I have made a type 1 error, I think that he is not an 80% free throw shooter, so I'm going to pick somebody else, okay? But he actually is an 80% free throw shooter, so maybe he's the best option. Okay, so in a type 1 error, I would not choose Coach Rivers, I would choose somebody else, but he might actually be the best option to make those shots on our team. Okay, if I made a type 2 error, I think that Coach Rivers is an 80% free throw shooter. So I would pick him to make those. But actually, he makes less than 80% of his free throws. So now I've lowered my chances as a coach of us winning the game. All right. So this comes down to when we have these 3 most common numbers for significance levels, which one do we choose? And it depends on whether we decide in the context of this problem, a type 1 error is more serious or a type 2 error. Okay, because the significance level is also the probability of making a type 1 error. Okay, so if a type 1 error is super serious, I might pick the lower significance level. All right, if a type 2 error is really serious, I might pick my higher significance level. If they're pretty even, or like in this Coach Rivers free throw situation, like nobody's gonna die if I pick the wrong shooter, we might just stick with the middle and stick with 0.05. Okay, so if I decrease the significance level, I am decreasing the probability of a type 1 error, but I am also increasing the probability of a type 2 error. Okay, so those things are a balancing act. All right, so if type 1 is more serious, I want a smaller significance level. If type 2 is more serious, I would want a larger significance level. All right, and that is the basics of a significance test.